Hello, everybody. Thank you all for coming to this session. I'm going to present this tool I call BITSInject. It lets you, as the local administrator on your system, to eventually run code as the system user interactively in session 0. It lets you do other manipulations on the Bit service as well. We will talk about the service and what it does legitimately and how we abuse it. First, a couple of words about myself. My name is Dor Azuri. I do now security research for SafeBridge in Israel in the R&D center. And in a nutshell, this attack on the Windows service is actually an attack on the serialization and deserialization mechanism. Serialization has always and will always be a very fertile ground to do this kind of attacks, to put arbitrary data and expect, well, unexpected behavior. I will show you how I use that technique to research and understand how we can manipulate the serialization and the structure of the artifacts that are used by the service to gain a lot of things, eventually gaining execution as the system user. So let's start to talk about the Bit service. It's actually not just a service. It's composed of both the service, which acts as a client, of a protocol. And the protocol itself is also called Bits and is defined by Microsoft. The service, the Windows service, is run in the background. That's why you see the last word. The second last, transfer. Why? Because this service allows any user on the system, on the machine, to transfer files. Now it can do both download and upload jobs. Each task is called a job. This is the term. And it is said to be intelligent. I didn't see an official explanation of why it's intelligent, but I guess two things are responsible for that word. One is the very advanced features that it allows. It allows downloading multiple files, downloading ranges within files, doing retries when errors occur on download, and a very special feature called the notification command line, which is a callback that can be defined on a job. This is very crucial for the method that I'm going to present. It is also intelligent because it facilitates a centralized place where all the jobs are calculated and being operated to optimize the bandwidth usage in the machine. And of course, it is run in the background. So, a couple more bits about Bits. It is here with us since Windows XP, since 2001. Since then, there were 5 major versions. We are now currently at version 5.0, and it is not that recent. It came out on 2012. Its most known use is the use that Windows Updates is doing. Windows Update downloads the updates from the Microsoft servers to your machine using the Bits service and the Bits protocol. Other software, very popular software, also use Bits to download updates. This is the typical and very common use of this service. One of them is Google Chrome updates, Microsoft Office, and OneDrive also can synchronize your files and folders using Bits. It has, as I said, many advanced features. Maintaining the job for a lot of time. You can define a job that will persist for weeks, months, and even more. You can define what to do when errors occur. You can register for the events that happen on your job, and you can do much more things with Bits. It's not just a regular downloader, it is much more. You can see a lot of the main events that occur in the service when you look at the event log and filter the Bits client source. Now, we'll start with the demo, not demonstrating the tool, demonstrating just an example of a software that uses Bits to download, just to give you a glimpse of something that you may have noticed or may have not noticed before, but happens when software uses Bits to download. So I'll open an hex editor called Neo. When I open it, you see that it checks for a new version and then gives me the option to download a new update, actually the new version. Just before that, I'll show you one way that we can look and examine the queue, the queue of jobs that the service maintains, and these are the download and upload jobs that are currently being handled by the service. So a way for us to look at the queue is a utility called BITSadmin. It is now deprecated. There are new PowerShell commandlets to do that, but this is more verbose. I found it much more easy and verbose to use than the PowerShell commandlets. So if we look now at the queue, this is just a reminder from a previous try. We'll start with an empty queue. We use the list command to list all the jobs in the queue. Currently, there are 0 jobs listed. Now, if we go back to the editor and choose to download the update and look at the queue, we can see 2 new jobs added. Actually, only 1 because it's already the downloading job. And if we look at some more details using verbose, you can see that the job is actually downloading an update from HHD software site to a temp location, and this is actually the new version that will be installed afterwards. We can intervene with that and actually reset the queue, meaning that all the jobs are cancelled. And as you can see, this software is registered to the job, to the events that occur, and it got a new event that the job was cancelled. And this is what's written there. It's too small to see, but the job is now cancelled without really doing it using that software, but from the BITSadmin utility. So this is just a glimpse to understand where it stands in your system. Now we'll go to a demonstration of the tool. I'll show you how with one click and a very easy interface, you can use the tool to spawn any process you want with the system permissions that will operate in session 0, which is the session where all the services, the OS services and the third-party services are running. So, sorry. We will use the tool, which is actually a Python script with an easy flag that all it needs is a path to the software that we want to start. And where is a good place to start? With a command shell. This is just describing all the steps that it's doing. We will go over in the talk all the steps and what are we doing here exactly. But we will wait a couple of seconds and we will get to a very strange place that I actually haven't seen before. Maybe if you sometime develop your own services, you've been there. But we got a pop-up, sorry you didn't see that. And we click on the pop-up and we are taken to this place. This is very strange place, nothing is here, not even Explorer, only you and the machine. And actually, you are the machine, you are the system. If you look at your permissions, we can list all the privileges, and you will see the different privileges the system has, while an administrator doesn't have. So let's go back to the real world. You can do very cool things with it when you are in this session interactively. Try to start the Explorer exe and see how many things don't work or work very strangely. So, yeah, so I didn't know that place in the first place. I was very amazed. How many of you have ever been in an interactive session with the system? So, yeah, so both of you, I saw yesterday with in your talk that you showed that different sessions can actually, different desktops from different sessions can interact with each other. So what you missed, and I will show you afterwards, is the pop-up that is actually the mitigation, one of the mitigations that you talked about, that tries to prevent from moving from interacting with different desktops, different sessions. So bits may be used by many clients. The built-in clients are BITSadmin, which is deprecated, like I said, and the PowerShell that replaces it. There are many other third parties, software, like I showed you before, that use that facility to make transfers. It is important to know that each job that is added by any of the clients has an owner. The owner is just the user that started and created the job. And then any other action, crucial action that's needed to be done on the job is done and checked against that user. That user is called the job owner. And the job can be of one of three types. It can be either download, upload, or a special type that Microsoft defined, upload reply, not in that scope. But all of the clients are eventually using the COM interfaces that QMGR proxy DLL hides, exports, and it hides the real implementation that's done in QMGR DLL. This is where the implementation of the bit service is done. So all the sources have to, the service has to handle jobs that comes from all the sources, and for that reason Microsoft chose to use a state file. This is a file on disk that's actually the DB, the current DB that BITS maintains. This is a presentation of the queue and the jobs in it in the hard disk. Why it is there? Mainly because BITS needs to provide a way for jobs to maintain even after restarts, even after any kind of event, and that's the obvious way to maintain consistency using the hard disk. Other non-malicious uses before that of BITS, it is used many times as a downloader. We've seen JavaScript that uses PowerShell commandlets to download the real malware. It is used, the last one is for C2 communication. It is a very good candidate for that because it can use proxies, it can use the default authentication of the machine, and it's a good way to bypass firewalls in that. This is actually, after all, this is just a protocol that is built on top of HTTP. It looks very good in the network. And it is used also as a persistent mechanism. One of the malware that uses this is zlob that defines the job with a callback, the command line, that will be executed after the malware is downloaded again. So even weeks and months after the job has ended, after the malware, the infected machine deleted the malware, you will see the malware getting back to the computer and even executed. So what was my inspiration? I saw many of the clients that use BITS, and the most special one was Windows Updates. Windows Updates, the service called Waweng, is using the BITS to download the updates. And what was my drive to start and look how it is done? I was jealous of how this service is adding jobs that the owner of them is system. Because Windows Update is a service by itself, and it is run as the system user. Why from the first place would I want to have system privileges? There are many reasons. These are some of them. It can open registry hives that are not available for an administrator to open, such as the security and SAM. This is where your NTLM hashes are stored. If it is run on a DC, it can access unrestricted access to the Active Directory domain service, and it can operate and identify itself as the machine itself. It can log on to services on the network as the machine, as the operating system, and not as any of the users. And it has a covered identity because everything you do as a system will be hard to identify whether it's malicious or is it a real action done by the system. If you see the difference between you do whoami/all and see all the privileges, if we try to get more exact. So this is the difference. You have some privileges, cool privileges. The first one is the privilege to change the access token from of a process level of a process. You can change the token that's in the process level and not just the thread access token. You can lock memory, means that you can choose pages in memory that will stay in the volatile memory and not be paged into the hard disk. And the TCB privilege is the one that lets you act as the operating system, and there are others. So we now know why we want to be system. We know how the bits generally operate. Let's dip into how we abuse it to gain system execution. So the main enabling feature we have is the notification command line, which is used with this API call to set notify command line. It lets you to define a command line that will be executed afterwards when the job ends, with the API to create process as user. So this is a very clear goal that I wanted to pursue. So my first try, and we'll go over the flow, and that's how we're going to understand how we made that abuse. My first try was to use BITSInject. When you think of ways to run system, there are other ways. The first and easiest is using the sysinternals BITSInject to run BITSadmin, that utility, to create a new job. So I create a new job with the name I want your system, and it is all right. I created the job. A new GUID is created, and the job is actually deployed into the state file. You remember the state file that manages and saves all the jobs. My next thing, after I created the job, I want to define what the job is going to do, to have a meaning. And the meaning I want to do is to download the software executable to ctemp. But trying to do that, I get this exception. Unable to add file to job because the operation being requested was not performed because the user has not logged on to the network. And this is kind of an absurd situation, because when I try to cancel the job, that is now has no meaning, I get the same exception. So in this case, the system acts like a god who created a job that he cannot cancel. And this was my first clue to go into the state file on the hard disk, because this was my only way to really cancel and reset the queue. So how does Wawang, which is the Windows Update Service, do the things it does and succeeds in creating a system job? How does he do that? So first, when we look, he switches to the call context of the COM service of bits. This is the first thing you need to do when you call COM API, COM external functions on a service, on a server that is on your system. So it switches to the context of QMGR, and then obviously the first call he wants to do is to create a job. And this is what we see here. And he defines a description for the job. If you don't see, it says WU client download. And if you look at the computer while it downloads updates and look at the queue, you will see at least one job with that description. And then he dynamically calls to create job from the interface that he acquired before. Next calls are add file, just like we use with the BITSadmin, and resume. When starting resume, this is where actually Bits starts to transfer the files. And the last two calls, transfer and begin download, are invoked already by Bits itself. This is not an explicit call that I have to make, or Windows Update in this case has to make. These are calls that are called throughout the execution of Bits when it decides that it is time to transfer a new chunk. So my methodology here was to go step by step with the flow, the original and the valid flow that Windows Update is doing, and the flow that made me fail using BITSInject, and find the reason. So the first call to create job succeeded, and in both flows, the parameters were identical, the result was identical, nothing changed. But when I look at the call to add file, the parameters were identical, but we got exception when we used BITSInject. And the reason, and that's actually, I'm going to present in a nutshell what I'm going to talk about in the next few slides, is that the reason is a bad pairing of the client security identifier and the session ID. Don't get confused of SID and session ID. These are two different things. And the real reason is that when I use BITSInject, I truly have system permissions, but I run in session 1. Actually, the session of where I am, usually session 1, but never session 0. So my solution was to fake the session ID. And I'll show you how. So a couple of words about two checkpoints that every action on a job has to overcome. The first one is actually a security boundary a very generic one, the access check. This is a function that you probably, many of you already know. This is in the heart of the security model, and what it does, it checks a thread access token or a trustee against the security descriptor of an object. So a job is the object, it has a security descriptor, and it has an access list inside it that is used to either grant or deny permissions to a thread. So what it does, and that iServer security interface is defined for COM services. It impersonates the client and then reverts to self, which means getting back to the token of the COM service. In the meanwhile, what it does is checks just like that the permissions to either grant or deny the action. So for those of you who are not familiar, an object has a security descriptor. Inside it has an access list. And let's take 2 examples of thread A, who has 3 trustees definitions, Andrew, and 3 groups. And he wants to get, read, write, and execute permissions on that object. Well, the first access list entry says that Andrew is denied of read, write, and execute. You can't be more explicit than that, so he gets denied. Thread B has Jane and group A as trustees to check, and Jane is granted on the second entry. Group A is granted write, and Jane is granted read and execute. If you sum it up, this access token has read, write, and execute permissions. The next checkpoint is actually not a security boundary. It's an operational boundary that BITS requires. Why? It makes sense because BITS doesn't want to continue to operate jobs when a user is not logged on. It becomes irrelevant from a BITS point of view. So it requires the user that performs the job to be logged on and actively logged on. So if we look at use Quinsta to see the log on the sessions that are on the computer, we see the little error on the second entry that we are on active session, the console that we are using. And the session ID is 1. In session ID 0, you'll see the services that's on your computer. So what is the real way that BITS is doing this check? It wants to switch to the logon token of the requesting thread of the action. And to do that, it wants to clone the user token. To do that, it iterates through all the users that are logged on and tries to find a user that is both in the session of the requesting session, of the requesting thread, and its security identifier is the one that is defined on the job. I remind you, each job has an owner, and the owner is actually defines the security identifier of the job. So the job gives this kind of check the security identifier to compare, and to find the session ID, the COM server QMGR uses the API get token information, and when we use BITSinject, this call returns 1, which is the session that we are running on. And because the job object has a security identifier of the system, and session 1 has no logged on system session, we get denied, because system is not logged on in session 1, it is always logged on in session 0, but never on another session. So how do we fake it? We put a breakpoint just before the call to clone user token, which is the second line, and did just the same thing with BITSinject. We use BITSinject to call BITSadmin with system rights, and we add a job, add a file definition to it, and when we try to add a file definition, we get to the breakpoint just before we get to the exception that we saw before. What we do is change the return value in memory of get token information from 1 to 0, and we bypass that check. This is how we get through this second security boundary after we already passed the first one, because we are actually with system permissions. And in that point, the job, and this is important to understand, the job is valid and it is in the state file, meaning that the service will continue to handle it. After we pass this check, we don't have to pass any other checks because Bits just trusts the file, and when Bits loads again or during its runtime, it loads the file and trusts the data in it. It loads the file and all the jobs that are in there and continue with their operation. Just for reference, many of the functions that are used to do the token manipulations and impersonations are inside a class called C-nested impersonation. And when all the checks are done, it uses the API impersonate logged on user to go and do the action as the actual user that requested it. So we actually now have a valid job in the state file, meaning it's in the queue, in Bits queue, but the first and initial state of each job that is added is suspended. And that means that no transfer and nothing is going to happen. So our next thing to do, our next challenge, is move it to one of the active states, like queued, connecting, transferring, and so on. So this is where the state file is playing a role. The state file, as I said, because the service trusts that file and loads the objects inside it to memory and to execution. This file is actually the supervisor. It represents the queue and all the jobs in it. This is actually two files in that location, QMGR0 and QMGR1, and they are updated alternately, like a kind of a backup model that I didn't dig too much into. But you can see that the current effective file is stated in this registry value. What's in the state file? It's a straightforward, unencrypted, and partially protected representation, binary representation of the jobs inside the queue, meaning that a string representation of the description or the name of the job will look like that. An integer stating the length, the characters, the Unicode characters, and an null-terminated string, a null-terminated character. And this is done by calling various calls to serialize and write, that write serialize the artifacts to the state file. It is unencrypted, meaning that when you open it with an X editor, this is really how you're going to see it, and it is partially protected. What do I mean by that? This is a file that is operated and affects the service that's run with system permissions, but administrator has permissions to stop it using scstop. And when the administrator stops the service, it can modify the file and then start the service again, and the modifications will load back to memory and the system will continue with the execution. So we went and reverse engineered the structure of the file and found the correct position where the state is saved, and just easily change an integer from 3 to 0, and we actually moved the state of the job to queued. This is the overall flow of how it's done. We stop the service, we modify the file inside that location, we put the new files, and we start Bits, and we have a new queue that is going to be executed and handled. And when we look using BITSadmin on the output of the queue, we see our job now with connecting state. The owner is the system, the integrity level is system, it is elevated, and it is going to execute the command line to spawn a shell when it ends or when it gets into an error. What is that integrity? Integrity is another way for Windows to differentiate different sessions of the same user and different abilities that it has. This is one of the things that allows the UAC mitigation or UAC pop-up, which lets an administrator to define what an administrator can do. So this is done by integrity, and the system has the highest integrity. But notice that up till now, in the overall flow that I presented, you have to actually replace the state files. And if there were any jobs before, you get a new queue, meaning that you overridden, maybe deleted any other jobs that were there. You don't want to interfere with the normal flow of bits. So surprisingly, if you just take that file and copy it to another machine, the other machine still executes it. So it is not machine dependent, but it is version dependent. There are slight changes between versions, but you can copy the file to another computer, and you actually get the remote computer execute the jobs that you defined on your own computer. And you don't have to have the ability to debug and put breakpoints on the remote machine. You just prepare the file on your computer and put it on another computer, and that's it. This is a glimpse of how the file looks using an editor. You'll see the template that is used to parse it in the GitHub that I'll present here, and you will see all the code of the tool and others. And now we wanted to, just what I said, to not override the whole queue, but to remain with all the queues, all the jobs that were in the queue before, and just inject our own job. So when we know the structure of the file, we found the counter. You just in the header queue, in the queue header, you increase it by 1 to add a new job, and find the place in the queue data to push the serialized job that you want to create, and you actually added a new job to the queue. And the tool, BITSInject, this is what it does, just what we explained now. It injects a new job, a serialized job, to the queue, and when the job finishes, it removes the job from queue. It allows many other actions to do on jobs. What I showed before in the demo is just the simple way to use it without getting into other parameters. And we can do much more in the future because we already know the structure of the file. But one thing we missed is the pop-up that went when the job finished before we were taken into the interactive session 0 session. And this pop-up is a mitigation that's here since Windows Vista. It is actually a service in its own called UI0 detect that runs and monitors other services that try to communicate graphically with the active desktop session. So 2 ways to overcome it. We are already starting as an administrator, so we can change the registry value to disable it. And another way is just make and execute the command line, the notification command line, without interacting with the desktop, not using user 32 DLL, not using GDI calls, and just making background calls, and you won't see that pop up. And this is what we're gonna see here in this second demo, this time on Windows 10. We'll see how we use a very simple program that doesn't interact with the visual desktop. And we start to look at the queue. The queue is empty. We have that write file.exe that just writes a file to ctemp. And we define this job. This job is going to be called demo. And it's going to download the file from my local host to a temp location. And then execute that program, write file.exe. So to serve the file, we use another development, a simple bit server. It's just a Python, very simple Pythonic server, a bit server that inherits and uses a simple HTTP request handler of Python. You can also find it in the GitHub. And now we start with the job. First new lines are the properties of the job. Its GUID, its name, its files that is going to download. And now the injection has started. First, we stop the service, we modify the file, and we start it again. Now, when we look at the queue, we see that new job. The state is connecting, the owner is system, the file that is going to be downloaded is defined here from localhost exe to ctemp exe, and as you can see, system integrity level, and we are elevated. We wait a few seconds for the service to load and start, and the job terminated with state 4, which means error. This is another state that causes the command line to be executed. We cause it intentionally to make the job run into that state and execute the program. And you actually see that bits tried 4 times. You can change that. Bits lets you define how many retries to do, and even afterwards maybe try days and months after. The default maximum is 90 days, but you can even extend that, and that's why you get a lot of persistency. And we look at the queue again, and we see that there are no jobs. What is the result? The result is a new file, ctemp. It's called bits stub file, and as you can see, the owner is system. So we didn't cause any pop-up, but we wrote a file, and we saw that it is with the system owner, meaning that the system wrote it. So write file executed as system. So the other side development is the bit server, simple bit server, and this is what allowed us to move the job quickly into an error state to quickly gain and execute the command line. It is just a way to accelerate it. You can also wait for the file to be downloaded. And one funny thing is that on Windows 10 you can do that without even requesting the file, without making any network traffic. You see that we had a get requests, but on Windows 10 you can modify the job where a property called the the volume serial number of the destination path, and if you fake it and it doesn't fit the real destination path that you provided, you get an immediate error and you get to the execution. So to sum it up, what were the enabling conditions for us to do that? One is that bits relies on the state file without verification. The second thing, it's a lack of unique machine identification, which let us to copy the state file from machine to machine and actually copy the queue. The third thing is inconsistent or partially inconsistent file permissions that's given to the state file, because if you you stop the service, you can modify the file and then start it again. And the file itself, the content, is a clear, straightforward serialization of the jobs. Now, other potential abuses that you can do and found along the way, this is actually pretty funny. You can choke a machine, choke a Windows update, and prevent a machine to download an update, a Windows update, because all updates are downloaded to that folder. And if you know in advance that an update is going to be downloaded, you go to that folder and you actually exhaust all the namespace that Bits uses. How it is done? Bits, before it downloads and create the file that you wanted to download, it creates a temporary file, a hidden file, and its name is of that format. It starts with bit, and it has 1 to 4 characters, hex characters. And if you calculate how many options there are around 70,000 options. So if you go there and you're the first one to create all the 70,000 hidden files, that they won't even be shown. So when Bits will try to download the file, it won't have a file to write to. And what you will see in Windows Update is just a generic error. Some updates were not installed. Windows Update encountered an unknown error. So it will take you a lot of time to understand what is the real error. And there's not a lot of help on Windows on Microsoft websites for that error. And you can do things just similar to how BITSInject is doing the injection to inject any new job that you want, to remove jobs, or to alter them while they are executing. I sent it to Microsoft Response Center, Security Response Center, and after some chat, the definition is that a malicious administrator can do much worse things. It is, you can see in Microsoft site what they define as a vulnerability or as a privilege escalation, and that's not defined as such, and they're not going to address that. These are the links where you can find the tool, the Bit server, and you can contact me for any other questions or other requests. Currently, it supports Windows 7 and 10. A POC was done on Windows 8, but no support is there yet. If you want, just hit me. That's all. Any questions?
Thank you. So, questions? Yeah.
So, first of all, great talk. I really enjoyed it. So, when did you discover it first?
Sorry?
When did you first discover it?
Around last May, I made a shortened version of that talk in DEF CON in July, and the response I got from Microsoft was around June.
Around June. And did you see any malware use it since?
No.
Because malware usually adapts really fast.
Malware, I did see malware using the other users of bits that I showed, but not that no.
So we have something to wait for. Great.
So, more questions? No? Then, thank you very much.
Thank you.